Hello and welcome to this biology session with Caroline Cymru. We're going to look at enzymes in this video and the effect of temperature and pH on enzyme action. So this is building on a previous video of enzyme structure and enzyme function. And we will pick up on a few concepts which are more relevant to the basic structure and function of enzymes, but focusing more here on how temperature and pH affect those aspects of an enzyme. So let's have a look at the first bit here with how you go about both describing and explaining the effect that temperature has on enzyme action. Now, it's important to appreciate the difference between these. A describe question, which is very common in GCSE papers, is very straightforward. It's say what you see, what's going on. You don't need to give any reason why. You don't need to explain, that is. You don't need to be using the word because. As soon as you use the word because, you're moving away from a describe and into an explain. And so in this video here, I'm going to sort of distinguish between my descriptions and my explanations. But we will cover them both at the same time. But you see, I've put the description is going to be in blue and the explain is going to be in red. So this is the start of the graph we would expect to see of how temperature affects rate of reaction. And as you can see, as temperature increases, the rate of reaction increases. And indeed, what I've just said there is my description. I haven't said anything as to why. I'm just describing. So my describe is in blue. So I'm saying here that as temperature increases, the rate of reaction increases. Whenever you need to describe, my advice, the easy way out is you just say as whatever is on the x-axis at the bottom of the graph increases, the whatever is on the y-axis, and then just say whether is it increasing or decreasing or indeed staying the same. People often struggle with description questions, and they should be straightforward. They're meant to be straightforward. They don't often carry an awful lot of marks, but they're common. And the key thing to remember is that you shouldn't be explaining. Just say what you see. So that's my description of that first part of the graph, which links temperature and enzyme activity, enzyme action. So let's now explain what's going on. So the reason, so as soon as I say the word because, I'm now in the explanation phase of the question. And you can see that I've put that in red for that reason. So the description was as temperature increases, the rate of reaction increases because by that having that increased temperature, both the enzyme and the substrate molecule move faster and therefore they collide more often. Collisions are required in order for the reaction to take place, a collision between the enzyme and the substrate, so that the enzyme can catalyze the reaction. So if the molecules are moving faster, they can collide more often. And that means you're going to form more enzyme substrate complexes. So if you recall, an enzyme substrate complex is a structure formed when an enzyme has bound to the substrate. And it's sort of a transient, an intermediate state. So before this happens, the enzyme and the substrate are apart from each other. They then bind or associate with each other and form an enzyme substrate complex. And the next step is that that substrate is converted into product. If we go on, continue with this description of what's going on, we look at that graph, you can see that, yes, to begin with, we've had this as temperature increases, rate of reaction increases, but then the graph seems to top out, seems to peak. And I've shown it there in black there. And that, we can only really do a description on that. And we just say that there is an optimum temperature, and it's the temperature at which the rate of reaction is fastest. So we might, if we were describing this, we might say, as temperature increases, the rate of reaction increases up to an optimum temperature at, and that would involve reading from the graph. And this would usually be around 40 degrees, but I mean, the idea is you read from the graph. All enzymes are different. They'll have different optimum temperatures and temperatures at which they work best. The reaction is fastest. But you need to use the graph there. It's what happens after is the point where most questions are focused, because then we get a steep drop in the shape of the graph. So let's describe what's going on there in blue. As temperature increases past the optimum, the rate of reaction decreases. It then decreases. So there's our description, but now we need to explain this. And this is because the enzyme denatures. Keyword in biology, when we're talking about enzymes, is the idea that an enzyme denatures when it gets too hot. However, let's explain what's going on there. Previously, in previous video, I've referred to the idea that the enzyme structure is held together by bonds, and the key aspect of that structure for the enzyme is the active site, because the active site is the part of the enzyme into which the substrate fits. So when temperature gets too hot, those bonds which hold the shape of the active site together break, and so the active site is lost and the substrate no longer fits into it. And that's what we mean by denaturing. The shape of the enzyme has been lost, so the substrate no longer fits. This is a picture of a normal enzyme versus a denatured enzyme, and you can see in the denatured enzyme that active site shape has changed and now is no longer the right or perfect fit for that substrate, and that's what we mean by the word denatured. Just need to be careful with questions that ask about this. So it's very common that you're asked about questions on how temperature affects rate of reaction. Probably 80% of those questions, possibly even higher, refer to the idea of the enzymes denaturing. But look to the question, look what it's asking, and use those key words. So if denaturing has not been mentioned in the question, you know there's going to be marked for saying the word denatured. And if it's 3 marks that are required and it's an explain, well, as well as saying denatured, you need to then give detail of what that means. The bonds holding the shape of the active site are broken and the substrate no longer fits. So you just need to be conscious of the marks that are being awarded, the number of marks being awarded, and the information that's already being given to you, because you will not get marks for giving information that's already been stated in the question. So let's just have a little look at a little activity I suppose you could do here. So as I've said previously, you're welcome to stop this video and see if you can recall any of these things. And if you can't, no problem. The idea is we're learning from this, and so you get better each time. So as the temperature increases, the rate of reaction increases. That's what's going on. You don't need to recall that. You can see that. That's what the graph shows. And the reason, because enzyme and substrate molecules collide more often. You can say they move faster too, but really the idea of more collisions is probably more important and more likely to be on a mark scheme, but using both of those terms, moving faster, so collide more often, is perfect. And that means it forms more enzyme substrate complexes. Okay, forms more enzyme substrate complexes. And then we have an optimum temperature, number 4 there, the optimum temperature, which the rate of reaction is fastest. Sometimes there's marks there for talking about what the optimum is, the temperature, but it's quite rare. But then as temperature increases past the optimum, the rate of reaction decreases. Again, you don't need to remember that because it is shown on the graph. And the reason for this is because the enzyme denatures, that's number 6. And what does that mean that it denatures? It means that bonds that are holding the shape of the active site together, they break, and now the substrate no longer fits. Okay, so that's how temperature affects rate of reaction, and it also doubles up as a distinction between describe and explain questions. Sometimes you're asked to describe, foundation tier, more likely to be describe, explain is more likely to be higher tier, and sometimes they're combined, describe and explain is put in one. So whenever people see a describe and explain question, they often panic a little bit and go straight into an explanation, but those are the harder marks. Describe first, get the early easy marks first of all. What about with pH? Well, pH questions are far less common, but here's the principle that every enzyme has got its own optimum pH. And so some enzymes, like those found in the stomach, have got a very low optimum pH of 1 or 2. Most enzymes inside the body prefer pH of around about neutral. But you don't need to know those. You may well be given information on a particular enzyme, like a graph like this with values on the bottom for pH, and be asked to identify what the optimum pH is. And it's a case of using the graph and reading down from where the peak is of the graph, reading down to what pH that corresponds to. Perhaps we need to know as well that if you go too far from the optimum, the enzyme also may become denatured for the same reason. It causes bonds to break, active site to change its shape, and the substrate no longer fits. But I would say 80% of questions about factors which affect enzyme action are on temperature. Okay, and certainly when it comes to asking sort of detail as to an explanation, that's more likely to be temperature questions. Same thing. If you want to pause the video, you're welcome to do so. I'll have a go if you can remember these things, but let's have a look. So this is just picking up from what was said before. As temperature increases, the rate of an enzyme catalyzed reaction increases because enzyme and substrate molecules collide more often to form more enzyme substrate complexes. Number 4, the optimum temperature is the temperature at which the rate of reaction is fastest. As temperature increases past the optimum, the rate of reaction then decreases because the enzyme denatures. And then when this happens, when it denatures, what that means is bonds, number 7, holding the shape of the active site break, so the substrate no longer fits. Last point, each enzyme has its own optimum pH, and if it's very far from the optimum, the enzyme may be denatured. And the fact that on that slide that I've shown you there, on that this part of the video, you're seeing most of that relates to temperature, is quite appropriate given it's far more likely to get a question on temperature. But we do see them on pH, and there's plenty to learn from them. And indeed, this question here is a question on pH, where they ask you to plot the information, the data that's in that table. So it's worth spending a little bit of time just going over this because it's such a common thing that is asked. It should be very straightforward. This looks like a foundation question to me because they are holding your hand through this 4-mark question. They're asking you to choose a suitable scale, so they tell you to do that. They ask you to plot results, and they tell you to join the plots with a ruler. Now, in biology questions, you will always be able to get away with, for want of a better term, to join your plots with a ruler. That's different in chemistry and physics, but it's nice to have a set rule in biology. Just join them dot to dot with a ruler. So they've also given you the values at the bottom, the pH values. Probably in a harder question, you'll be asked to choose these values too, but that's what's on the mark scheme. So you get a mark for putting a linear scale on. You must include a number at the origin. So this is my linear scale. I've got a number at the origin. What do I mean by linear scale? Well, I go up in regular intervals. I go up in 20s. If I had 10 at the bottom there, well, that would be incorrect because I'm going up in 10 for my first large square and then 20 for the next. That's not a linear scale. But you must make sure you have something at the origin. It does not need to be 0. It's a very common error that pupils tend to think that, no, the most common area is they miss off a value at the origin. And the next thing that can cause problems is they think they have to start at 0, and you don't have to start at 0. When it comes to plots, you see there's a tolerance of half a small square, and you've got 2 marks that were being offered for that. So do your plots, and then it's a case of joining them together with a ruler. A key point, you do not they've deliberately given you pH 5 here. They're testing you to make sure you do not join to the origin from the value you've got pH 6. Your line joining together the dots should only extend to the limit of your data. So you shouldn't go beyond the data. So you shouldn't be going below pH 6 or above pH 8.5 because those are the values that you've been given. You cannot take it upon yourself to decide what's going to happen at pH 5 because you don't have any data for that. So you mustn't plot that. And indeed, for pH 9, you can't join it down to 0. You don't know what's going to happen at pH 9. You don't have data for that, so you shouldn't do it. So that's quite an important thing to note when you're plotting graphs. Here's another question which carries on from that. From the graph opposite, describe in detail the effect of pH on the activity of amylase. So I'll ask you to describe in detail. So they don't have to explain, and indeed what makes this probably a bit easier is that in pH you're never asked to explain. Temperature you are, but they just ask you to describe, so don't worry about why. But there's 2 marks, so it does say describing detail. So you just saying increase then decrease is going to be very much a gamble, because you're suggesting you're going to get a mark for increase and then a mark for decrease, but they've asked for it in detail. So here, 1 mark for saying increase then decrease, and the other mark for saying that there's the optimum of pH 7.5. So you're still using that term optimum there, but it's whatever you've got on your graph is what you should be referring to. But if you've plotted your graph correctly, that's how it should look. Another question here. So you've got diagram A, B, and C as representing the lock and key theory of enzyme action. It talks about the enzyme protease, which is this enzyme here, which splits or breaks the bond between the 2 amino acids. That's the job it does. It asks for the name given to the structure represented by B. That's the enzyme substrate complex. And then it asks why the denatured protease D is unable to catalyze the separation of the 2 amino acids. So here I've got the marks here and I've highlighted what I think you should be saying here. So you can say the active site is changed, but really you should be referring to explaining this now, not saying what happens, explaining the bonds in the active site are broken. That's what happens when it denatures. The bonds are broken, and that means the substrate can no longer fit into the active site. And finally, state 2 factors which affect the rate of an enzyme-controlled reaction. Well, now we've covered these, haven't we? It's temperature and pH. There are others, but the ones that we talked about today and the ones they're really expecting you to say, and they appear first and second on here because they're expecting you to say that. But it is indeed true, and at A level we might talk about how concentration of substrate and concentration of enzyme do affect rate of reaction too, and they're going to award you marks for that, even though really what they're expecting there is temperature or pH. One thing to notice though, you'll never get away with saying the term amount. I mean, I'd say it's a rule, just don't say amount. Okay, don't say amount. It should be well, temperature, pH, what they're after there, but concentrations really are more relevant. I have a tentative rule. I say if you say amount, put a cross next to it, because amount in biology never gets you the mark. They're after words like concentration. They do allow words like volume and mass if they're appropriate. In this place, in this question, it's not appropriate to be talking about volume, but volume is the standard SI unit. Just saying amount is really you saying I don't know which unit to use, so I'm going to hide behind that and just say a vague term of amount, and so you're never given those marks. So worth mentioning that, or for me to mention that, so you're aware of that. Just don't say the word amount. You're hiding from using the correct term. You are better off guessing either concentration or volume or time or mass or whatever it may be. You're better off guessing one because you're not going to get a mark for saying amount. Okay, hope you found that useful. So just identifying those key things again. There's other videos available from the Caron Company website, so please feel free to go and check those out. And I hope you found that video useful for enzyme factors affecting.